What if I told you that two people doing identical squats could see completely different muscle growth results? Even more shocking, what if the deciding factor wasn't their genetics, training program, or diet, but something as simple as how they breathe during exercise? Right now, millions of people worldwide are performing the same exercises in gyms everywhere. Yet the way they breathe during these movements creates a massive divide between those who see explosive muscle growth and those who struggle for months with minimal progress. Wrong breathing patterns don't just limit muscle development, they actually increase injury risk. Researchers at the German Sport University Cologne conducted an 8-week study with 180 participants that revealed extraordinary results. Despite performing identical strength training routines, the group using proper breathing techniques showed more than double the muscle growth compared to those using conventional breathing patterns. The hidden mechanisms of breathing and muscle growth. Most people think of breathing as simply oxygen delivery. However, breathing is a complex physiological process that directly influences muscle development in ways most fitness enthusiasts never realize. Proper breathing during exercise doesn't just optimize oxygen levels within muscle tissue. It actually changes muscle fiber contraction patterns. Research shows that correct breathing techniques during peak effort moments can increase muscle activation by up to 40%. More importantly, breathing directly affects core stability. Strategic breath control regulates intra-abdominal pressure, stabilizing the spine and enabling you to handle heavier weights safely. This translates directly into stronger muscle stimulation and accelerated growth. How wrong breathing sabotages your gains. The most common breathing mistake in gyms worldwide is breath holding throughout entire movements. This technique, called the Valsalva maneuver, can generate momentary power bursts but becomes counterproductive when extended too long. Prolonged breath holding causes blood pressure spikes and reduces blood flow to the brain. This leads to decreased concentration during workouts, ultimately compromising exercise quality. More seriously, it cuts oxygen supply to working muscles, causing premature fatigue and limiting performance. Another destructive pattern is shallow chest breathing. This stress-induced breathing style, common when people feel tense or anxious, overactivates the sympathetic nervous system and increases muscle tension. Tense muscles cannot achieve maximum contractile force. Scientifically proven optimal breathing patterns. The American College of Sports Medicine provides clear guidelines for exercise breathing. Exhale during the exertion phase when lifting or generating force, and inhale during the lowering or relaxation phase. However, this basic pattern is insufficient for maximum results. The real game changer involves strategic use of diaphragmatic versus chest breathing. Before workouts and between sets, deep diaphragmatic breathing activates the parasympathetic nervous system, promoting muscle relaxation. During actual exercise, chest breathing forms the foundation, but the most challenging portions require short, powerful breaths to maximize momentary power output. This technique is called power breathing. Exercise-specific breathing strategies. Squats require inhaling deeply while descending and exhaling sharply during the most challenging portion of the ascent. The key is maintaining adequate abdominal pressure throughout. Complete exhalation destroys core stability. Deadlifts demand even more precision. Take a large breath while gripping the bar to increase intra-abdominal pressure. Begin gradual exhalation as the bar passes your knees, completing the breath as you finish the movement. Bench press involves inhaling while lowering the bar to your chest, and exhaling while pressing upward. However, during the sticking point, the most difficult portion of the lift, briefly hold your breath to generate maximum force. The science behind breathing and muscle activation. Electromyography studies reveal that proper breathing techniques increase primary muscle activation, while reducing unnecessary tension in opposing muscles. This means more efficient muscle recruitment and ultimately superior growth. The interaction with core muscles is particularly crucial. The deep core system, composed of the diaphragm, pelvic floor muscles, transverse abdominis, and multifidus, works in harmony with breathing to provide whole body stability. When this system functions properly, it creates a stable foundation, allowing limb muscles to generate maximum force. Disrupted breathing patterns collapse this entire system, dramatically reducing exercise effectiveness, oxygen saturation, and muscle development. Muscle growth requires adequate oxygen supply, but it's not simply about delivering large quantities of oxygen. The timing and distribution of oxygen delivery makes the crucial difference. Proper breathing techniques enhance capillary dilation within muscles and improve oxygen delivery efficiency. Studies show that groups using strategic breathing patterns achieved 15% higher muscle oxygen saturation compared to conventional breathing groups. Even more interesting are the recovery differences. Proper breathing accelerates post-exercise lactate clearance and significantly reduces muscle damage markers, enabling faster recovery between training sessions. Breathing's impact on hormone production. Few people realize that breathing patterns directly influence hormone secretion. Deep, rhythmic breathing promotes growth hormone release, while stabilizing cortisol levels. Post-workout cool-down breathing is particularly important. Deep breathing during this period activates the parasympathetic nervous system, promoting recovery. The growth hormone and IGF-1 released during this phase play essential roles in muscle development. Conversely, shallow, irregular breathing increases stress hormone cortisol, which can promote muscle breakdown. This explains why identical exercises produce different results, depending on breathing quality. Practical breathing techniques for immediate application. The foundational technique is the 4-7-8 breathing pattern. Inhale for 4 seconds, hold for 7 seconds, then exhale for 8 seconds. This method stabilizes the nervous system during pre-workout preparation. During exercise, employ the 2-to-1 breathing ratio. Inhale for 2 seconds and exhale for 1 second, maintaining balance between oxygen supply and force generation. For heavy lifting, use modified Valsalva technique. Take a large breath before movement initiation to increase intra-abdominal pressure, but gradually release breath upon movement completion, strengthening your breathing muscles. Breathing itself requires training. Strengthening respiratory muscles like the diaphragm and intercostals improves overall exercise capacity and breathing efficiency. Simple respiratory muscle training includes balloon inflation or breathing training devices. Just 10 minutes daily for 2 weeks. Increases lung capacity and stabilizes breathing during workouts. Advanced techniques involve resistive breathing training. Special masks or devices add breathing resistance simultaneously, improving respiratory muscle strength and endurance. The mind-breathing connection. Breathing affects exercise performance mentally as well as physically. Anxiety and tension naturally cause breathing to become shallow and rapid. This state prevents proper muscle relaxation, limiting maximum contractile force. Conversely, calm, deep breathing stabilizes the mind and enhances concentration, improving exercise quality. Mindful training, combining meditation with breathing techniques, is already utilized by many elite athletes. This approach trains not just the body but coordinates breath and mind together. Environmental factors and breathing efficiency. Exercise environment significantly impacts breathing efficiency. Poor air quality or low oxygen environments limit effectiveness, regardless of proper breathing technique application. Indoor training requires adequate ventilation and air purification when possible. Fresh outdoor breathing before and after workouts provides additional benefits. High altitude or low oxygen environments emphasize breathing technique importance even more. These conditions require more precise breath control than normal environments. Hydration and breathing connection. Many overlook the relationship between hydration and breathing efficiency. Dehydration thickens blood, reducing oxygen transport effectiveness. Proper hydration before, during, and after exercise enhances breathing efficiency and facilitates oxygen delivery to muscles. Extended exercise sessions also require electrolyte replacement consideration. Dry mouth naturally leads to mouth breathing, which is less efficient than nasal breathing. Adequate hydration helps maintain optimal nasal breathing patterns. Individual breathing pattern optimization. No single breathing pattern works optimally for everyone. Lung capacity, body type, training experience, and health status influence. Optimal breathing patterns. Beginners should focus on establishing basic breathing rhythm. Consistent patterns matter more than complex techniques initially. Intermediate and advanced trainees can customize breathing strategies based on exercise type and intensity. Understanding your body's specific needs enables effective breathing strategy development. If this video helped you understand the power of proper breathing technique, please subscribe and hit the like button. Turn on notifications to receive the latest evidence-based fitness insights delivered directly to your feed.